Well, good afternoon, or good morning, or good evening, depending on where you are in this world. Thank you for attending today's DevOps.com webinar. Is a monolith standing in the way of your digital transformation? Refactor for better agility. Today's webinar is being recorded. Just wanted to let everybody know that. So if you have any issues during this webinar or you miss all or part of it, just know that on the DevOps.com website there will be a link to the webinar and to the slide deck. You'll also be receiving an email that has that link in it. Okay, today's webinar, Refactoring Monolith Applications and Monolithic Applications. It's a great one from IBM, and we do have two great speakers. Bill Alexander, who is architect, IBM developer for Z Systems, and Paul Piloto, who's solution architect, ADDI at IBM. Welcome, gentlemen. Thanks for joining today.
Yes, hi. Good morning, good afternoon, good evening, like Charlene already said. So my name is Paul Piloto. I am a solution architect with the focus on application discovery and delivery intelligence and DevOps on System Z. I have more than 30 years of experience in the enterprise modernization space and had the opportunity to work with tons of mainframe customers from all over the world. I will focus today on what monolithic applications are, what their bottlenecks are, and how ADDI can help to break them down. Bill?
And I'm Bill Alexander. I'm an IBMer working in the architecture and development team for Application Delivery Foundation for Z Systems. Paul's got me beat by a few years. I've got only about 25 years of experience in this field. And I will be discussing some new tooling which we just delivered last week that will help you refactor those monoliths into smaller, more modular components.
Okay. So we have the traditional disclaimer, and as we will talk about future features that will come in the products, we cannot commit to any dates, but this is a well-known disclaimer slide, so everybody probably knows what this means. The agenda of today's webcast is to define what we understand to be a monolithic application and how the monolithic application, in a lot of cases, became a monolithic application. Once we understand the complexity of those monolithic applications, Bill and I will walk you through the different reasons and scenarios why refactoring becomes a need, and we will show you some approaches on how our tooling can help doing that. What are the different business drivers that motivate people to refactor monolithic applications? First, there is business agility. The speed that our marketing and business experts expect from IT to change faster their solutions and respond faster to this disruptive business needs is one of those motivations. Microservices, which is in contradiction with monolithic applications, is today the answer to respond faster to these needs, because often the core business processes don't have the change that often, but have to integrate with these new digital business needs as soon as possible. By accelerating the digital transformation, you can provide more flexible and reusable capabilities to these needs. Another important business driver is to get new people, the millennials or the Generation Z today, up to speed with our core business and give them the opportunity to learn faster what we have, by providing them a more understandable architecture of those applications. It also enables you to eventually rewrite into modern languages, such as Java or Node.js, in an incremental approach based on smaller components to rewrite, and this to reduce the risk and the cost of that rewrite. Before client-server or browser-based architectures became trend for our day-to-day IT thinking, monolithic applications were commonly used and accepted, not only in the mainframe spectrum, but common for all platforms. The need for separating presentation logic from the business logic and separating data access logic from the business logic wasn't there, and it was much more easier for a developer in function of logical unit of work or of ease of deployment, that the logic that belonged to one screen was handled in one program. Over the years, these monolithic applications, monolithic programs got changed over and over again because of new business needs or new business products or an acquisition and merger that happened, business regulations that had to be applied to the applications. We have known the year 2K and so on. So a lot of reasons why applications grow in size. Often the developer retired or moved to another job within the company or even left the company, and these monolithic applications just grew and grew in size and functionality. Successor developers were so afraid of making mistakes or breaking the spaghetti code that they preferred to copy and paste portions of the logic and made their changes in the copied source, and often left the original code inside the program, which then became dead code. This resulted in unmaintainable masterpieces to which a successor developer, millennial, or outsourcer, or even the original developer was afraid to touch it because it functionally worked and became a monster to maintain. Another problem came along when the tester community popped up. They had to write testing scripts for these little monsters and had to understand how the code worked in order to guarantee an acceptable code coverage percentage. And let's not even think about creating an automation in testing these code icebergs. It is doable, but the test cases will be monolithic as well. There is absolutely no agility in monolithic applications, and every little code change involves a compile, involves full testing, and involves a packaging of the full functioning monolith, which all costs lots of CPU consumption, just because the impact of the change is hard to predict. And let's not forget the pain they cost when new business needs pop up. For example, to open some of the logic as a public API or integrate the business critical functionality with a new mobile solution. Or even when there is no business need, if IT wants to move forward with an hybrid DevOps solution, these monoliths are a leftover from when teams deployed infrequently and they remain a pain. If you don't do anything about them, no change, no digital transformation, no integration with new technologies, you might well end up like this monolithic Godzilla monster, destroying your business because IT didn't shift gears with their legacy. When we want to move forward into the API economy or want to integrate mainframe development and deployment within our continuous DevOps process, if we want to automate our testing processes and make sure that during this testing, code coverage percentages get guaranteed, above all this, we implement agility in the development process because we can parallelize development and deployment and testing. We can conclude that refactoring is the solution to these monolith programs' problems. There are several business drivers for refactoring. One of them is that we want to move forward into an API economy. Using application discovery and delivery intelligence, or ADDI, to understand the monolithic application and use application delivery foundation for System Z to refactor them and thus make it possible to use ZOS Connect to make a public or on-premise used API to please our business in order to make our valuable business critical logic available to partners or to other in-house projects. A first scenario in this API journey is to break big applications into smaller ones. Like I said earlier, ADDI can easily identify the code that is somewhat loosely coupled. By the use of ADFZ, we provide some refactoring wizards that make these loosely coupled code into an independent callable program. Bill will extensively talk about this new feature in IDZ or ADFZ. That is more easy to unit, so this callable program is more easy to unit test and to turn into a RESTful API by running it through the ZOS Connect wizards, passing it the interfaces such as a Kickscom area, for example. Application Delivery Intelligence will optimize the testing efforts by recommending which and how many test cases you have to execute when source code is changed. Another important business driver is the demand for creating and govern business rules. ADDI will capture business rules information, including business terms such as a contract or a claim or a financial transaction, etc. In the current roadmap and near future, ADDI will identify these candidate business rules. Again, ADFZ will provide a refactoring wizards to turn those candidate business rules into manageable and executable logic through, for example, IBM's ODM. And last but not least, we better refactor our monolithic applications because we want to integrate our valuable legacy applications into our hybrid DevOps process, because smaller units are more agile and easier to maintain and manage, and thus also easier run through testing automation tools. Code coverage percentages can also be guaranteed and followed up, and code review can be made much more agile. This is the point in the refactoring process where ADDI and ADFZ come into play. They are basically the GPS for your mainframe source code. Application discovery will take you through your applications without getting lost in the complexity of monolithic applications. ADFZ or IDZ will help with new features of refactoring. And delivery intelligence will help in keeping you on track when it comes to agility in testing and making test recommendations without going in all the testing details. However, you still need to know where you want to go. Tools are not the self-driving car equivalent. In application discovery, we offer different reporting facilities which use industry standard metrics and algorithms. It is proven that these metrics make it more easy to estimate realistic timings for making a change. We can produce a McCabe complexity report which presents cyclomatic complexity in a number of linearly independent paths through a program module. Or we can produce a Halstead complexity report which can be used to compare the complexity between two programs or two applications. A heuristic complexity report determines the complexity of an application by assigning values to each type of statement available. A maintainability index report is a measurement report that is intended to track maintainability to indicate when it becomes cheaper or less risky to rewrite code instead of changing it. Call graphs and all kinds of usage reports should make the discovery process easier for a person who has to make refactoring decisions. And that code reports should remove the code that has been copied and pasted over time for reducing the fear factor of a developer who had to touch a working program by making a small change and who opted to copy the original code and made his change into the copied statements and leave the original code in the program. That is how these monolithic programs became. Once we decided which programs are typical monoliths we want to refactor through running the reports, we can then go into discovering the programs individually by looking at them using graphs within the application discovery analyze client, as demonstrated in earlier presentations probably. The program flow graphs present the internal structure of a program, including all referenced files, SQL tables, screens, and other programs called. It visualizes the flow of the performs, go-tos, calls, PL1, procs, etc., as you can see in this screenshot. By analyzing the program flow chart, which you see here in a screenshot, the developer gets a better understanding of the structure of the program in a statement and decision tree level. This gives the programmer a better understanding of relationships within the logic of a monolithic program. All these features help to accelerate the refactoring process because it reduces the guesswork about the side effects that might be the result of a change. Application discovery has lots of features to navigate through the monolithic applications more effectively, and gives the person who analyzes a better and faster understanding of the unknown. Application discovery offers a more structured approach for preparing and change because all of the visualization features is there in the tool. Last week we released application ADDI version 5.03, which has some new features. A significant one is this graphical artifact independency analysis, which you see a screenshot from, which captured data at runtime during testing and static analysis data that is combined together to produce an application composition map. This diagram is annotated with visual indicators, highlighted programs which are violating the code complexity, maintainability, and code coverage thresholds previously defined by your organization. This allows you to rapidly assess and plan changes to the problematic programs and also assess a high-level impact of making the program changes. This graphical analysis allows you to size the change and the overall maintenance effort, thereby reducing the risk in your own DevOps process. And in the new release, we also made some other feature enhancements, as you can see in the list. Bill, I would like to hand over to you.
Okay, thanks, Paul. So as Paul just mentioned, last week we released Application Discovery and Delivery Intelligence version 5.03. We also released at the same time Application Delivery Foundation for Z Systems version 3.1, which is a bundle of other products, and one of those products is IBM Developer for Z Systems version 14.1. So besides the refactoring tools, which are, I'll discuss more in the next couple slides, the new IDZ release also has additional integration features when application discovery is installed on top of it. And so those features include in-context analysis for KICS transactions, database tables, and MBS datasets. It also, IDZ 14.1 also includes support for open DevOps toolchain products such as SonarQube through on-the-fly analysis of COBOL or PL1 source code when the Sonar lint plugins are added to IDZ. And it also includes day one support for the new IBM Enterprise COBOL and PL1 compilers, as well as the upcoming next release of DOS, and then many other requests for enhancements that have been submitted by our user community. And then here is a shameless plug for a blog that I wrote the other day regarding the new features for the new release, and you can check out that URL at the bottom to give it a read. So after the developer gains a complete understanding for the program logic by using the impact analysis reports and the visualization tools in ADDI that Paul just described, he can now use some new refactoring capabilities for COBOL source that's included in IDD 14.1. So once the desired logic is selected, the available options include creating a new program, creating a new copybook, or extracting the selected logic into a new paragraph or section within the same program. So by creating a new program from the chosen existing logic, the functionality provided by this logic is rapidly made available for use in new ways. As part of the refactoring process, the original monolith will be updated so that it invokes the new program, and this preserves the existing functionality that the monolith had previously. But the new program that gets created can now be exposed as a service. And Paul alluded to this, it doesn't matter whether you plan to restrict the use of this new service only to your own internal applications, or whether you intend to expose this new service as an external API. Just the creation of individual functional services allows organizations to quickly adapt to changing business requirements. So too often we see that business logic that could provide your companies with competitive advantage if it was made reusable is instead locked away inside these monolithic applications. And attempting to duplicate this logic on another platform or in a different language can lead to things like errors or redundancy. So instead, refactoring the logic into a reusable module can create new business opportunities, as well as continue to support the existing application. So IBM z/OS Connect Enterprise Edition provides a single common way of invoking services for modern mobile, web, and cloud applications. The z/OS Connect API editor, which is the tooling for z/OS Connect Enterprise Edition, can be used to define RESTful APIs and map the API request to the traditional back-end interfaces such as COBOL copybooks. It also allows for the assignment of static values or the removal of unwanted fields in order to simplify the API for the consumer, whether it's a mobile or web application, what have you. So traditionally, these monolithic programs contain many different function paths, and each requiring different input data potentially to produce their expected results. So this scenario causes lengthy manual testing. Even for small changes, you need to schedule in a lengthy test cycle in order to fully regression test the monolithic program, and it makes the creation of automated test cases that much more difficult. But if we were to refactor that program into individual components, then with each one providing discrete functionality, then that makes it easier to create automated regression test cases. And the input and the expected output becomes well known to each of these individual components. This can often reduce the overall testing time and improve the testability and the amount of code covered during testing. Using automation, test automation, and creating automated test cases, you can uncover defects earlier in the software development lifecycle. You can have this slide is actually out of date, but so the earlier that you can find the defects, the less costly they're going to be to fix. And there's several different DevOps tools available to assist with test case creation and automation. Some of these offerings include a feature of IDZ itself. It comes with the IDE. It's known as ZUnit, the ZOS Automated Unit Testing Framework, and that's for for developers who are developing unit tests. And then there's another product called Rational Test Workbench, which not only provides API testing, but also allows for service virtualization, so returning mock data to those services to allow independent testing to go on while the service is still from the consumer, while the service is still under development. And there's XA Tester, which is a unit testing tool focused, unit testing focused offering from Exact Consulting, who's an IBM business partner, and MF Test, which is an automated testing offering from another IBM business partner called Most Technologies. But regardless of the tool that you choose, creating and running automated test cases becomes easier after a monolithic application has been refactored into smaller components. Test automation in general can improve the confidence that the changes that you're making to your software are not causing regressions. And it's this confidence that really allows for more frequent software delivery, accelerating the time to value for your application changes. So on the last slide, I just mentioned a few tools that can assist with defining and running test cases. And another key benefit to refactoring is the ease in which code coverage results can be obtained and examined. ADFZ provides a code coverage collector, which you can use in conjunction with any of the tools that I mentioned previously, or even in cases where you're conducting manual tests. Those code coverage results that are collected during test case execution can then be combined with cognitive capabilities of application delivery intelligence to produce trend information. ADI has the intelligence to guide the tester in deciding which test cases to execute based on the lines of code covered and those that were changed. This visually identifies gaps in your test cases, which can prevent you from leaving the testing phase without properly testing the code that was just delivered. The guidance that ADI can provide could also potentially identify redundant test cases, allowing the same programs to be tested with close to or equal code coverage score as your previous test runs, without having the need to execute all of your test cases. This type of knowledge can lead to a reduction in the overall testing time while keeping the high quality code that you desire and a high level of confidence in your test cases. So besides the opportunity to create APIs or to improve testing, another benefit provided by refactoring is increased agility. Separating a monolith into smaller components allows multiple developers the opportunity to work concurrently. Parallel development can occur for each module that requires changing, rather than linear development where you've got programmers waiting for the single monolithic program to become available so that they can make their changes to the one single program. Deployment flexibility can also be achieved, as oftentimes only the component program that was modified is required to be deployed. Of course, it depends on the nature of the change, as sometimes the monolithic program, which invokes the component program, may also need to be deployed, but that's not always going to be the case. In addition, as technologies change over time, these loosely coupled components provide the flexibility for implementation changes without disruption to their consumers. So for example, if an application was using a VSAM file previously and the data access logic has now been separated out into its own module, it becomes easier to replace the data store with a different type in the future if desired. So far, I've mostly been talking about creating component programs from a monolithic program. However, even simply creating copybooks for common code or extracting logic into paragraphs to improve program flow and readability can reduce the complexity of a program. Using these other refactor options in IDV can make the code easier to read by humans, and sometimes these techniques can also improve industry standard measurements. Paul had mentioned earlier about the Maintainability Index, which is calculated measurement that's based on cyclomatic complexity, and cyclomatic complexity is a pretty well-known measurement that was introduced back in 1976 by Thomas McCabe, as well as the Halstead volume, which is another well-known metric, which was introduced a year later by Maurice Halstead. Application delivery intelligence tracks trends in these various metrics. So you can see in the graphic on the right that maintainability index and delivered bugs, as well as other things like lines of code and others are tracked over time. And this information allows teams to quickly understand just how complex or hopefully easy to maintain their application code actually is. So in summary, refactoring is the process of improving the structure of software without changing its external behavior. And refactoring monolithic software into smaller functional components can improve the extensibility of a function by making it reusable either inside or outside of the current application. Refactoring can also assist in adopting DevOps practices like continuous testing by making it easier to create automated test cases. These automated test cases, when combined with code coverage results, can provide continuous feedback, giving developers confidence in the changes that they've delivered. Having a high level of code quality and a separation of functional components can also allow development teams to deploy more rapidly. This differs from the more traditional, infrequent deployments that we've seen in the past because of monolithic software. And of course, Any developer who's taken over support for a pile of spaghetti code agrees that well-structured code is easier to understand, maintain, and evolve as both functional and non-functional requirements change. So whether your goal is creating APIs or improving testing or improving maintainability, IBM has tools like ADFZ, ADDI, and the OS Connect Enterprise Edition that can assist you on your journey. I thank you for your time today, and if there are any questions, I think we'll turn it back over to Deb, and she can
actually
let us know if we have any questions. Oh, Charlene's going to take it? Okay.
Yeah. Okay, great. So we do have a couple questions that have come in so far, but if you do have a question for Bill or Paul regarding any part of this presentation, or just in general about IBM Z mainframes or something like that, feel free to go ahead and get your question in using the control panel. Okay, so let's see. The first question: how can we integrate with other products, such as SCM, workload automation, things like that?
Okay, I will answer this for the ADDI portion. So today we have very tight integration with non-IBM and IBM SCMs, of course. We have currently integration with Serena Changeman on the mainframe. We have integration with CA Endeavor, which is also an SCM on the mainframe. We have an integration with RTC, which is our own distributed SCM. And we have many other integrations with SCMs such as Subversion and etc. So we have integration for what concerns application discovery and delivery intelligence. For the IDZ part, I would prefer that Bill would answer this one.
Yeah, sure. Okay. So for IDZ, we have built-in integration with SCMs like RTC and Endeavor and SCLM, and there are and because IDZ and really all of the tools that are in ADFZ are Eclipse-based offerings, different vendors make their own plugins that you can install on top of our products to provide additional integration. And our products are using our own DevOps practices. We have a continuous delivery pipeline for about 17 products, I believe it is now, that are all built and tested together and integrate with each other. And those, to find out more about those products, you could go to developer.ibm.com/mainframe, and there you'll see a list of all of the different Eclipse-based products that we have, which can be installed together and integrate with one another.
All right, great. Thanks, guys. The next question: how do you store and manage the analysis data?
Okay, I think this is a question more for application discovery. So we store and manage the output of the analysis on a relational database. A relational database today is SQL Server on a Windows platform, but we are working very hard to get it also available on DB2 and all the platforms where you could run DB2, like Linux or native ZOS or so we store and manage our analysis data on those databases. Does that? I hope that answers the question.
Okay, great. Let's see. Okay, next question: is the analysis repository data kept up to date, and if so, how?
Okay, that's a logical next question. So yes, the data is kept up to date and can be scheduled. So we have For the mainframe SCMs that we analyze, like Serena Changeman or CA Endeavor, we have listeners that agents that run on the mainframe and that communicate with the build server, which is sitting on a Windows machine at this moment, and which then will populate the changes, the deltas of the programs that have been changed on those SCMs, and will store those changes onto the repository. You can make that scheduled, so that means that you can do that on a daily base or on a release moment base or anything you would like, or even on an hourly base. So you can keep the repository up to date as you like. I think that's the answer.
Okay, all right, great. Just a reminder to you guys, if you have a question for Bill or for Paul, go ahead and just use the control panel, submit your question that way, and we'll try to get to as many questions as we can. The next question is, let's see, how can I enforce coding standards?
So I can take that one, Paul. Okay. So coding standards, one of the things that I mentioned is new for IDZ version 14.1 is integration with SonarQube. And so SonarQube has a set of rules and dashboard, and they have plugins which can plug into IDZ 14.1, and those that's one way in which you can enforce your coding standards. IDZ itself also has some tools built into it by its own that can help in this fashion. So, for example, there's a formatter within the editor. So, if you have people writing code, or you're refactoring code into a new program, and you want it all to be formatted the same way, you can run formatters against the code to make sure that it is easier to maintain because it all looks the same. And there's also a set of rules for each of the languages that are distributed with IDZ. And those can be run against the software to identify code violations, as well as AD, Application Discovery, also has some rules that are available and can be run at analysis time. So whether you're interested in identifying these or keeping these coding standards, known to the developer while they're developing the code, or known to the team after application discovery does a scan, there are different options available depending on what you use.
All right then. Okay, let's see. Okay, next question. How do you handle dynamic calls?
I think the question is also with regards to application discovery. We have built in a feature, I would say, in application discovery that gives you a translation table between the dynamic calls and the possible calls that your program can make. So at least that in the diagram, in the graph, you will see the possible calls that can be made. Now, if the dynamic call is that dynamic that the data is read out of a database call, for example, and comes from database information, then it becomes very difficult for us because we do static code analysis. And static code analysis means that we can only analyze what is written into the code. And like I said, we have a feature that provides input to that static code analysis that you can say, okay, this program, the possible calls that this program can do is this, 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 and this. In that case, we can show that in the graphs. But if the calls are read from a database and are dependent on the logic, then of course it is impossible to do this analysis. But we have a feature that gives you a translation table between the calling program and the possible called program. So at least we have a feature that gives the capability of showing the dynamic calls.
Okay, great. Here's an interesting question for you. How long would it take for a 10-year mainframe programmer to be effective with ADDI? Of course, I'm sure this is a totally subjective question, but on average, would you say?
With ADDI, if the programmer has Eclipse knowledge, knows how to use Eclipse because the analyzed client is running an Eclipse-based interface. So supposing that this developer has Eclipse knowledge and knows how to drive an Eclipse IDE, then I would say within less than a week he is capable of working with ADDI.
Okay, great. Hopefully that
helps.
Because
the tool is very intuitive,
yeah,
and it has a lot of predefined queries that you can run against the database, and it has a lot of graphical representations of the program, so it is really very intuitive to work with. But again, it runs on an Eclipse-based client, and that might probably be more of a hassle for somebody who works for a long time on the Z side than the tool, than AD itself.
Okay. All right, great. We do have time for some more questions from the audience. If you guys have something that you'd like to ask either Bill or Paul, please feel free to get your questions in now. We have a couple more that have just come in. Another question, these tools focus on individual programs rather than applications with hundreds or thousands of programs. I guess he's looking for clarification there.
So I can take this one. So IBZ is a development environment for application developers. So similar to ISPF, you're only going to really be editing one program at a time. Although because it's an Eclipse-based IDE, you can certainly have multiple windows open and do editing or analysis on multiple programs. But when we're talking about refactoring, we are talking about running those wizards or those tools on one program. ADDI, on the other hand, is doing static analysis scans on all of the source that you want it to. So your entire application could be hundreds of programs, just like you mentioned. Paul, I don't know if you want to talk more about that.
Yeah, so I can elaborate a little bit on that. So hundreds or thousands of programs, and AD application discovery has the capability can repartition your different applications into what we call projects. So you can define different projects within application discovery, and you can still do analysis over different projects. So for example, if your complete application portfolio is like 20,000 programs, let's say, but you have functional domains, those 20,000 programs are divided over 20 different functional domains, then in application discovery, you can, for each functional domain, you can represent it as a project. And still you can go and do analysis over the different functional domains. So to see where the functional domains are interconnect with each other, which are the interfaces between the different functional domains. You have a circular view, which I like very much, and that gives you that shows in a graph your functional domains that belong together and where they are integrated. So it has a lot of capabilities and gives you a very good possibility in analyzing your full application portfolio. Of course, if you would do that, if you would like to do that analysis overnight, then the first time it will probably take some time to do the full analysis. But once you have it all loaded in your repository and you just have to go for the deltas, it is a great tool to keep track of your applications in a very short period of time.
Okay, excellent. Okay, I've got a question here that may be coming a little out of left field, but Rhonda is actually asking about IBM blockchain software integrations, whether there's any information that you can provide on that. I'll take that as a no.
No, it doesn't mean a no, but it's a very, it's not I would say it's not a yes or no answer. By going through this digital transformation, if you have monolithic applications, I cannot imagine that you can make them blockchain available or integrate them in a blockchain architecture. But if you have more functional, smaller components, APIs that you can probably integrate them in a blockchain architecture. Because blockchain is probably calling out to your, in some extent, is calling out to some of your business critical functionalities. But if those business critical functionalities are kept secretly in a monolithic application, you will probably have a problem. If you can extract the logic of that business critical functionality in an API, then you can integrate with blockchain. I think that would be my answer.
Okay, great. Well, I appreciate you answering that, and I'm sure Rhonda does as well. And actually, with that, we are out of questions for you. So we're going to go ahead and close out the webinar a few minutes early today, but I did want to just remind folks that if you missed any or most of the webinar or all of the webinar, you can refer back to it via a link that's going to be emailed to everybody who signed up for the webinar. The link will take you to the devops.com site, which will also have these slides attached to it. So fret not if you missed any or most of today's webinar. You still have access to it on demand. And please also check the devops.com website for upcoming webinars. We've got a whole slew of them listed, so please take a moment and take a look through and see what we've got. But for now, I would like to thank our panelists today, Bill Alexander and Paul Piloto. Thank you both for joining me today. I really do appreciate it.
You're welcome.
Thank you. It was fun.
Great. Well, everybody, thank you again for joining us, and I'm signing off now. This is Charlene O'Hanlon. Have a great day.